Here is our objective, that upon finishing this video, you would be able to 1. Identify the parts of a pie graph and its use, 2. Learn different types of pie graphs and be aware of misleading pie graphs, and 3. Analyze pie graphs. Pie graphs is derived from our pies, which are sliced differently into different sections or different slices depending how big or how wide the slice is. Pie graphs are invented by William Playfair in 1801 and adapted by Florence Nightingale to make it more readable. Here are the parts of a pie graph. For example, given this pie graph, the topmost is the title. The category label gives us the description of what the section is all about. The sector is the space itself of the whole area of that column, just like here, for example, the whole orange area is the sector. Then the percent value gives us of how many percent it is compared to a whole. As pie graph is the best graph when we are trying to compare a part to the whole. The parts are represented by percentages and illustrated by the width of the inner angles of the sector. How are pie graphs created? Okay, pie graphs are created by getting the percentage of the ratio of the part, the whole, and multiplied it by 360 degrees. So like this, take this for example, your favorite pet. So we have dogs, cats, birds, fishes, and others. For the dogs, you have 18. For the cats, 10. Birds, 5. Fishes, 4. And others, 3. So first, we're going to get the sum of it. 18 plus 10 plus 5 plus 4 plus 3. We give 40. So you have to add another 3 columns. So divided by total times 100. So 18 divided by 40 times 100, that will give 45%. 10 divided by 40 times 100, that is 25%. 5 divided by 40 times 100, 12.5%. 4 divided by 40 times 100, 10%, and 3 divided by 40 times 100, that is 7.5%. So that gives a total of 100%. When it comes to making the sectors of the pie, we have to consider that a whole rotation gives us 360 degrees. So let us take, for example, this is a 360 protractor. So we have to know how wide is the inner angle of a certain sector. So we divide by total, 18 divided by 40, but this time we will multiply it to 360 degrees. So 18 divided by 40, we have 162 degrees. 10 divided by 40, we have 90 degrees. 5 divided by 40, 45 degrees. 4 divided by 40, 36 degrees. And 3 divided by 40, 27 degrees, with a total of 360 degrees. So in order for us where to start and where to end, we need to put the degree stop. Degree stop will be derived by adding the angles accurately. Let's start with 162 degrees for the dog. 162 plus 90, that gives us 252 degrees. 252 plus 45 degrees, we have 297 degrees. 297 degrees plus 36 degrees, we have 333 degrees. And 330 degrees plus 27 degrees equals 360. So this is now how we create our pie graph. Then we label. So as you can see here, 162 degrees, we start from 0 going to 162. Okay. Next, 252, we start from there, 162 going to 252. That is our sector on cats. Then from 252 going to 297 here. that goes to our birds. Then 297 going to 333 goes to our fishes. And the remaining sector, we have others. Okay. So getting the 360 protractor, we have our pie graph. You only add to add the labels and the title. So there are different types of pie graphs. First, we have the simple pie graph. Then others for aesthetic purposes, we have the 3D pie. And we also have the donut in which the area inside is taken out, but the area inside should be distributed equally in all of the sectors. We have also pi of pi. For example, we have here others. How many percent is that others? It is still broken into other sectors. And the bar of pi. What consists of the sector? Let's take, for example, favorite fruit. We have the apple, the grapes, and then others. What consists of that others? You can put there oranges and other types of fruits. A perspective 3D pie graph is used to give the chart a 3D look, often used for aesthetic reason. The third dimensional does not improve the reading of the data. On the contrary, these plots are difficult to interpret because of this distorted effect of perspective associated with the third dimension. So, as you can see here, item C appears to look larger than item A, but when it comes to the regular pie chart, item A is much larger than item C. In a 3D pie chart, the slices that are closer to the reader appear to be larger than those at the back due to the angle which they represent. This effect makes leaders less performant in judging the relative magnitude of each slice when using a 3D than a 2D. So, when we are trying to make an aesthetic pie graph, let us refrain from extremely rotating the third dimension pie graph in order not to mislead readers. So there are other developing aesthetic designs. Different templates and themes rise into the internet in which you can just edit it for more appealing in your business or other presentation. When it comes to monochromatic pie graphs, different patterns or shades of black and gray are recommended in order to give distinctions between different categories of the. So, let's practice. Example number 1. A graph shows how a children's sports camp spend its weekly budget. So the sports camp weekly budget is $2,250. And these are the different slices on how the budget is allocated. Question number 1. How much does the sports camp spend on lunches each week? So we have here 35% lunches. So that is 35% of $2,250. That will give us 0.35 multiplied to 2,250 will give us 787 and 50. So the sports camp spent $787.50 on lunches each week. Number 2. What percent of the total sports camp budget is spent on equipment and umpires? So we have equipment 18%, umpire 11%. We only have to add it. 18% plus 11% is 29%. 29% of the total sports camp budget is spent on equipment and umpires. Number 3. What fraction of the sports camp budget is spent on permits? So permits is 8. That means 8 in every 100. So 8 in every 100, 4 in every 50, or 2 in every 25. But we will use the 8 out of 100. So 8 in every $100 of the sports camp budget is spent on permits. Last question number 4. What amount does the camp spend each week on busing? So busing is 28%. 28% of 2,250, that is equivalent to 0.28 multiplied to 2,250, that gives us 630. The sports camp spend $630 each week on busing. Let's move to our next example. Example 2. A graph shows where your energy dollars go. So in every dollar, we have this one. Where do your energy dollars go? Question number 1. According to the graph, what percent of the average energy bill is spent on drying clothes, lighting, and heating water? So, what percent? So, we have drying clothes, 3, lighting, 5, and heating water or water heating, 17. So, we have to add them. 3 plus 5 plus 17, that is gives us 25. 25% of the energy bill is spent on drying clothes, lighting, and heating water. Question number 2. A family's energy bill is $180. Assuming the family's energy use is typical, how much did the family spend on water heating? So, if in every 100 in every 100 cents or $100, we have 17, okay, dollars. That means 17% of $180. So 17% of 180, that is equal to 0.17 times 180. That gives the family spent $30.60 on water heating. You may check into your calculator for um, for validity. Number 3. Which section is greater than 50% of an energy dollar? So when we say 50%, that is half. Okay? So which section is more than half? So obviously, we have the biggest one, heating and air conditioning, 60%. So the answer is heat and air conditioning. Number 4. What energy cost is about 1/10 of the energy dollar? In order to know, we have to find the percent form of 1/10. So 1 divided by 10 or 1/10 is equal to 10%. So which of the percent here is closer to 10%? Is it 60, 17, 11, 5, 3, and 4? So the most near is 11%. So that is approximately to 11%. And the answer is cooking and refrigeration. Okay, let us practice more. Time spent on task by record clerks, Wood County Recorder's Office. So if this is their time, the following section are divided to what are they doing within their offices. Question number 1. During a 40-hour work week, how many hours does a record clerk spend preparing documents? So we have 40. Okay? So preparing documents is here, 25%. So we have to find the 25% of 40, 0.25 times 40, that gives us 10. So our answer is A, 10. Question number 2. What percent of a record's clerk time is spent on tasks other than data entry? So here are our options, 25%, 31%, 44%, or 56%. So the record's clerk time on task other than data entry. So our data entry here is 44%. So the rest of here, filing, preparing, we have also service desk. Since everything is 100, we only have to subtract data entry 44. So 100% minus 44%, we have 56. Our answer is letter D, 56%. But there are many ways to kill a cat, as they said. So we can also have 25 plus 25, that is 50, plus 6%, that still gives us 56%. Okay, for our last example, we have the graph 4. The employees of National Bank are given the following. So how your dollar retirement is invested in cents. Okay, so this is a monochromatic pie graph given the different shades and patterns in the sectors. For mortgages, we have 20, we have public bonds 40, we have real estate 7, stock market 3, and private bonds 30. Okay, so this is 20 cents, 40 cents, 30, 7 plus 3. There is a total of 100 cents, which gives us also $1. Okay, so this can be presented by the percentage of a dollar. Number 1. What percent of each retirement dollar is invested in real estate and the stock market? So we have A 4%, B 10%, C 40%, or D 90%. So what percent of retirement is invested in real estate and stock market? So we have real estate 7, stock market is 3. So we have 3 plus 7 equals 10. Okay, 7 plus 3 equals 10. Our answer is letter B. Question number 2. Steve contributes $120 of each paycheck to his National Bank Retirement Fund. How much of each contribution is invested in public bonds? So public bonds here is 40 or 40%. So that is times $120 equals $48. Letter C. So I believe this makes up the video for today. And before I end, I would like to congratulate everyone, or to those who have watched this video, that you have now completed all the lessons about graphs. Let me end my video with a food for thought. If we only give God a part of our life, we see others, family, career, friends in their corresponding percent. But with God in every part, we have here God is 50%, but if God here inside is 100% in every part, we see the miracle grows, that our time with family is doubled, as well as our career, friends, and other things in our life. So make each day and make every time with God, and He only will give you abundant blessings. Thank you for watching and have a nice day.